it tells you kind of different estimates. Those are the different colors, but basically everything, hovering around 6.5 million deaths resulting from air quality. And when you look at it on a geographical basis, where is this focused geographically? You can see that. So the top left is the number of deaths attributable to PM 2.5. What's PM 2.5? It's fine particles less than 2.5 micrometers in diameter. And we'll have our next speaker kind of go into that a little bit. But basically, you can see the number of deaths. You have a larger focus in the Asian region. India and China kind of top the list. But then you also have, other parts of the world with, high early mortality resulting from these fine particles. On the bottom right is the welfare loss as a result of the air pollution. And it's estimated, this is from a World Bank report, it's estimated it costs more than $5.1 trillion globally each year in terms of welfare losses. And the way they estimated it is they take into account the value of a statistical life, like attributing everything with a dollar value. And economists can probably explain this a little bit better, but in terms of what is it, how do you value your life in terms of what do you have to trade, to have better air quality in terms of convenience. Those types of things kind of go into this calculation, and that's how they come up with this estimate. So it's definitely a very grave problem. And of course, recently World Health Organization has declared it as, an important problem to address. So to manage air quality, so we have this high concentrations, we have this, early mortality. To manage that, you need to know where it's coming from. For that, one component of that management framework, what we call as a air quality management framework, is measurement. So you need to be able to measure it to see what the concentrations are, and then kind of track it back to sources, and then decide, okay, what type of pollution control policies would work. So typically on the very left is what's called as a reference methods. That's what's certified by EPA to be accurate. And these are obviously point measurements. These are spatially sparse because these are expensive instruments. And that's obviously the gold standard that everyone looks to. And on the far right is the low cost sensors, which is what all of you are going to help with. Be helping with. These are also point measurements, but since these are relatively cheap, we can have a larger spatial coverage. So you can help fill the gaps that these gold standards can't, just because it's cheap, and because we have regular citizens who are interested and they buy their own sensors as well, just because they're interested in knowing what the air quality is. And so that's on the other end, but the disadvantage with that is it's not that accurate. So there are some issues with the accuracy of the data. And so depending on what you're going to use it for, we'll need to make some data adjustments. And so that's the compromise that we have. One on the left is the far left is a gold standard that's accurate, but it's expensive. You can't have it spatially, it's just spatially sparse. On the right, you have this low cost sensors, but your trade-off on accuracy. Now in the middle, you have the satellite data, which is, provides global spatial coverage. Which you can't afford with either of these measurements. Even though you have these cheap sensors, you can't deploy this pretty much through the entire globe. And that's where the satellite data comes in handy. And you'll hear from our collaborators on what it measures and what it means. But basically, that's looking from the top, and it's just looking at what the particle loading is through the entire atmosphere. But it's the whole column and not just what's at the surface. And so that's where this project comes in, is where all of you citizen scientists are going to help, is to see if we can have a low-cost sensor-based network. That's the far right sensor there, that can help fill the gaps, or help increase these point measurements on the ground, and then relate it back to the satellite data, which already has this broad spatial coverage, and estimate what the concentration is on the ground. Because that's what matters, because that's what we all breathe, right? So that's the air quality that we breathe, and ultimately then results in health impacts. And so that's the overall goal. And so in order to do that, then to make it sustainable, the citizen scientists help in kind of spreading this around and having a sustainable network. And also ensuring that the sensor works fine, it's reporting good data quality, and if it's not reporting properly, then maybe communicate with us. So I kind of went over this project goals. So the goal is to collect the spatially dense. So how do we kind of increase this measurements on the ground, improve those estimates using these sensors deployed by a community of citizen scientists. The idea here is to make it cost effective, sustainable, and engage and motivate citizen scientists to deploy the sensors, as well as to generate widespread usage of NASA data. These are available free of cost. It has a lot of value. There's a lot of products issued by put out by NASA. And so how do we make these generate a community citizen scientists who can interact with these data sets? I have a couple of scientific questions that's listed there for those who are really interested. So the key goal that we're really interested in examining is what is the spatial gradient in PM2.5? In other words, how does it vary geographically? And how does it compare to what is observed by satellites? Now, are these low-cost sensors going to be useful to help correct that and generate a better estimate of the data, and also help inform these current and future NASA missions? So those are kind of the two scientific questions where, which the data that you're going to collect will help, answer those questions. This one kind of gives an overall picture of what it is we are doing this project. I'm not going to go into too much into detail, but we had phase one where we tested whether this is even going to be feasible. So we deployed about 100 sensors in California and tested it out whether these sensors run for at least a year or so. And so once we found that, then we are now in phase two, where we are expanding the deployment in California, here in this region of North Carolina, as well as in India. And the idea is to look at different concentration ranges. So as far as US is concerned, perhaps Los Angeles is on the higher side, but globally, when you look at it, you saw that India, peaked the chart. So we have 3 different concentration ranges, Delhi being the highest range, California, the midpoint, and then Raleigh for the really clean, low end part of the spectrum. So these are just some results from phase one, where we tested whether these sensors are reliable, whether they can operate over time. And the key finding that we found out was that these data tracked the gold standard, right? But they are not accurate. They have large biases depending on which sensor you look at. So basically the take home point there is we need to have these data adjusted for it to be useful. And so that kind of shows there the number of sensors that were deployed during the phase one. We had a similar type of workshop during phase one in California that shows there kind of engaging them during the workshop. We also had a paper led by our collaborator at NASA who looked at the utility of these sensors. So we looked at the data from California, actually all of California, not just the Los Angeles region, but pretty much all of California, where other citizen scientists who have deployed these purple air sensors, outside our project. So we took all of the data and compared it to what the satellite showed for a particular wildfire event back in 2017. And we found out that the sensor data were useful. Even without those gold standards, we were able to relate to the satellite data and get the same level of prediction that you would if you were using the gold standard reference methods. And so that kind of showed us, okay, this is useful and definitely potentially viable tool to help improve those estimates on the ground. And so that kind of brings us here as to how you all as citizen scientists can help. And I think we already kind of went over a little bit of what it is that we'll be doing. Karmann, did you want to do this or you want me to continue? Sure. So obviously, the first thing is to be able to host and maintain these sensors. So these sensors are the one that we are giving you. We'll go into more detail on what it is, but there's really not a lot of maintenance involved. So we try to find something that is not too cumbersome. But what we also found from phase 1 is because it's not too cumbersome, you tend to forget that. But what we would request is maybe just periodically check the data and let us know if it's working or not. If you find it to be really odd in terms of the reading, let us know. So there's really not a lot involved in maintaining the sensor, but just hosting it. It requires a wireless connection, internet. If you have a specific interest in examining questions of your own, we are here to kind of help. So if you can, maybe provide tools to extract satellite data, compare it between satellite and sensor data to answer questions of your own. Interact with other citizen scientists, people in the room here, and perhaps even those from California and India. Interact with them. We are trying to have a framework in place. We do have a forum on the website, but we'll try to improve that maybe a little bit. We'll see. But I think trying to get the citizen scientists interacting with each other and engaging. Keep us informed of sensor performance. I talked about that. Send us metadata information. So what do I mean by metadata? We'll get into that a little bit more later in the afternoon. But basically information that would help us evaluate the performance of your sensor as well as correct the data, right? And this is probably just going to be a one-time thing, or maybe anytime you have something that you think would impact the response that you're seeing. We would like to know where it's located. Is in the backyard, roof? Maybe send us some pictures so we can have it, allocated with that record. Did you have a cookout there, or is your neighbor doing a barbecue? That might maybe influence the results that you're seeing. Was there a fire nearby? And does the value relate to what you think the air quality might be? If is it really too high or too low? And so that would kind of help us do some QA, quality assurance, of the data that you all are collecting. Karmann, I'll probably turn this over to you.
Yeah, I think we had a sensor before that was near a car fire, that like a car was on fire in somebody's neighborhood, and that's why they saw a peak on their sensors data. It's like, of course, that would, a car fire? Yeah, and if you have like a chronic smoker that lives next to you, these kinds of metadata help us when we're looking at the population of sensors in the area to hone in on, oh, well, we know why that's high. We know why we're seeing that peak. So we have a lot of opportunities for how to participate in this project as you're looking at your sensors data, or as you're looking at the population of the sensors in this area. If you know of an event, you can send it to the project website, send it in to us so that we know about it. And we have opportunities to get engaged. First of all, we have a blog on the website that if you have noticed something, or you have asked a question of the data and come to your own conclusions, we'd love to hear about it and hear a story from you. Even hear about how easy it was to install your sensor and get it registered. Any anecdote that you'd like to share, send that in, and we can include a picture, include a reference to you, and that would be a great help to not only us, but also your fellow citizen scientists. We also have a few Twitter accounts across the group here that you can start following, and we'll send out an email with more information about social media stuff. But if anybody uses Twitter, there's a few accounts to follow and a few hashtags to follow. I'll send that out later. And the Purple Air sensors that you've all received, so that's the company that manufactures them. If you're on Facebook, there's a Facebook support group for users of these sensors. It's called the Purple Air Users Group. And you can join that Facebook group, and a lot of people will not only post what they're finding or seeing from their sensors, but they'll also ask questions, and someone from the company is in the group and answers questions. Oh, golly, there's so many options of how to just be involved on an everyday basis, but Bottom line for this project, there's a big event that we will be planning for the last year of the project, this next, in the end of 2020, beginning of 2021, a workshop for citizen scientists in Washington, D.C. So what we would like to do is, since we're going to be engaged, you guys are going to be engaged, we'd like to do an invitation to some of our group here that is particularly involved over the next year for you to join us in Washington, D.C. for this workshop, and we will be able to pay for your travel expenses. You don't all jump up and be excited at once! Ah! So Washington, D.C., not just for workshops and conferences, but also a really amazing vacation location. Historical landmarks, museums, spas, yeah, good food. There's a lot of good food in DC these days. So anyway, we're really looking forward to that workshop, and we will be doing invitations to those of you that are particularly engaged with the program over the next year. So hoping to let you know that right now to incentivize you to stay engaged, stay connected, and keep up with the project.
Wonderful, thank you. All right, I think that kind of brings us to the end of this presentation. So that's our project website if you haven't been there. So it's aqcitizenscience.rti.org. That has information on the project, and we'll get into this a little bit later. Megan will be presenting that later this afternoon.